Hi guys, welcome to our channel of Sciences and Mathematics. Today we are going to look at a concept in mathematics, and that is the concept of trigonometry. The basic concept of trigonometry is very essential in our day-to-day lives, now that it finds applications in various areas like in mathematics, whereby we can use it to find the unknown angles in figures, and also in architectural work where it is used in construction, and also in satellite navigation and other areas of geography, maybe seismology and etc. So for that case, we're going to look at different areas where it can be applied. But of essence for today is going to try to assist us develop what the concept of trigonometry entails, and some of the relationships or the rules like the Pythagoras theorem that we may come across, which have a direct relationship to this concept of trigonometry. So without further ado, thank you and welcome. So as I've said, today's topic of discussion is going to be trigonometry. And basically trigonometry, as I've said, is a branch of mathematics that deals with the relationship between angles and the sides that form the angles. And before we go further, I can just have a small recap so that we can be able to develop that definition and try to understand what basically this concept of trigonometry entails. When I was trying to do the introduction to geometry, we say that we can have a point in space, maybe point P, and arbitrary point in space P, and then if we have a corresponding point Q still in space, the shortest distance between the 2 points P and Q can be illustrated using that one, and that is going to form a line from point A, from point P to Q, and if it's moving in that direction, then we can denote that line as PQ. So therefore, if I have another line that runs from point A to point R, and the shortest distance, I'm saying about the shortest distance between the 2 points because that's a straight line. The line between P and Q, which is the shortest. Of course, if I decide to take a different route, I can be able to take that one. But now that one is going to be another distance, which is not a line. So a straight line is the shortest distance between P and Q. So therefore, if this point runs from P to Q, then I have 2 points, that is P and Q, and they are having a junction at point P. So therefore, the illustration for R, P, and Q forms a space, as I can say, an extension in between here that we refer to as an angle. So therefore, this is what we call an angle. And if this point begins from point P and extends infinitely in that direction, then we call this one a ray. So therefore, we can just have 2 rays. So the junction between 2 rays where they originate from point P, or the space between the 2 rays that are originating from point P, is what we call an angle. So therefore, we're going to see how this concept develops into the concept of trigonometry, and therefore we are going to have a definition of our term, that is trigonometry. So therefore, trigonometry, as I've said, is a branch of mathematics that deals with the relationship between angles and the sides that form angles. A branch of mathematics that deals with the relationship between angles and sides that form the angles. Now, from the concept of the rays that I've spoken about, that is from point P to R to Q. Now, there's a relationship that will exist between this angle that is formed in between here. Let me just give it a notation of theta, and the sides. Let's say this side may be M and there's a relationship between the angle that is formed here and the sides that form this particular angle. And we're going to see that that relationship exists when it is defined by a right angle, a right triangle, which is a figure, a three-sided figure that develops from this concept of the rays. So the intersection between these 3 points, PQ, RPQ, forms what we call a triangle. And when this triangle has got two rays which are meeting at a right angle, therefore we call that one a right triangle. So therefore, in this case, we're going to see that these angles that forms after the intersection of those particular rays at a right angle are being denoted using that specific symbol. And sometimes maybe we can be able to use Greek letters to refer to angles. These include letters like beta, like the one that I had used initially. This is gamma, beta, alpha, omega, etc. These are some of the denotations that we are going to encounter when we are trying to differentiate between different angles of figures, like the triangle that I've listed on the board. So in this case, these are some of the notations that we are going to use in trigonometry in trying to imply angles. So in this case, we're going to see the concept of a standard angle. Now that we have said what an angle is, intersection between the two rays. So we're going to see the concept of a standard angle. Now if I give the figure that I just mentioned about the P, Q, and R, and then there's an angle theta that is formed in between here. This is side X and Y. There are specific names that you're going to assign to those particular sides and the angle that we've talked about. But an angle in standard position is the one that is formed in a rectangular coordinate system. So in this case, we're going to see that these angles can be formed by figures, but there's a reference system that we're going to use in order for us to determine maybe the length between P and Q, Q and R, or P and R, using maybe specific formula or theorems like the Pythagoras theorem. But this is going to use the concept of a rectangular coordinate system, but of course we normally use and we know as the XY axis. So in this case, I'm going to have X here and the Y axis. So the change for these angles, suppose this point of origin is at the center, the difference between P and Q can be able to be determined by finding the range on the X axis and the Y axis. So suppose I have this rectangular coordinate system, basically, which I've just drawn on the board. So this is known as a rectangular coordinate system. And this rectangular coordinate system, we're going to see that there are different ways in which we can be able to represent. Now, suppose this array that runs from this point infinitely towards that direction. There's going to be an angle that is going to be formed between the intersection of this x-axis and that ray. From the point of origin, let's denote it as 0. So therefore, we're going to have x as the horizontal axis and y as the vertical. That is going to be the vertical axis. So in this case, the angle in the standard position, as we have said, is the one that is formed in a rectangular coordinate system. So with whatever angle that we are going to use or to refer using this particular system is what we call an angle in standard position. So therefore, angle in standard position, we have come across some specific terminologies like standard units, etc. So an angle that is going to be formed in that case, in the rectangular system, coordinate system, is referred to an angle in a standard position, in a way that the vertex for this angle is going to be located at this particular center. It's going to be the vertex, bearing in mind that the vertex is the end of those specific angles at the origin formed by rotating one ray from a fixed ray. So in any case, if I have an array from the x that is running across or maybe along the x-axis, and I try to rotate it either clockwise or anti-clockwise direction, then I'm going to form what we call an angle. The extent to which that ray is going to be rotated is going to form an angle. So in this case, if I rotate it that way, or in this position, I'm going, so bearing in mind that I'm rotating relative from this position, and I'm going to form an angle maybe in that or this. So in this case, I've just rotated it in a clockwise direction to form angle theta. So we're going to have this basic angle. Now suppose the extent of this arc is to this point. I mean the extent to that particular ray is to that point. And we're going to see that, just do away with this, now that we've explained what it is. Now suppose the extent to this arc is to this point, and therefore I'll have rotated it to that point, and it will have formed what we call an arc. So the distance between the point, the original point, and the extent to which it has been rotated is what we call an arc. We're going to have a specific name for that. And at this particular point of the arc, then we're going to give this particular extent for the x and y direction as x and y. Now that one represents the rectangular coordinates for the extent of motion in the x and the y direction. And we're going to see that, as I said, this is what forms what we call a right triangle. So therefore, if I decide still, I can be able to rotate this around this coordinate system, and it's going to form what we call a circular path. So therefore, or maybe I can just call this one an intercepted arc. Intercepted arc. So the whole range of that one is an intercepted arc. So we're going to see that this intercepted arc runs a full extent of that intersected arc runs for 360 degrees, and this 360 degrees from the basic concept of a circle is going to give us what we call a circumference. Therefore, we can have a relationship between this extended arc and the degree measure of this particular angle. So in this case, the degrees are going to be measured using, I've just introduced this concept earlier, but the degrees measure that is going to be either theta, gamma, alpha, omega, etc. or beta are measured in what we call degrees. Degrees, and these are denoted using that small symbol there. So in this case, when we're talking about the intercepted arc running across from the origin and returning to that specific point is measured, it circumscribes what we call a circle. What form that forms a whole range of this distance that is known as the circumference. So from basic mathematics, we know that the circumference can be given as 2 pi. Can be given as pi d, and now we know that d, or the diameter, is equivalent to 2 radius, or to 2 radii. So therefore, this can be given as 2 pi r. So implying that the extent of that intercepted arc, if it runs a full cycle, then we're going to have 2 pi r as 360 degrees. Therefore, one of the 360 equal arcs around the circumference of a circle whose center is the vertex of an angle forms what we call a degree. So therefore, if this runs for 360 degrees, a single arc from this 360, or a single division for this 360 degrees, one division, just you put it arbitrarily, one division of 360 degrees forms a degree. So there's a mathematical relationship you can find from there that if the whole cycle is 360 degrees, then therefore one division forms a degree from this case. So that is bearing in mind that relative from the point of rotation, which is the vertex, an extent of a single arc forms 1 degree for this 360 degrees. So the degree measure of an angle is therefore the number of such arcs in the intercepted arc of a circle which is centered as the vertex. So the extent to which, if there are 360 arcs and one arc is representing a degree measure is the extent to which this particular ray has just extended from this point of origin. So therefore for our case here, theta is our degree measure that can be given in form of degrees. Now there are two different ways in which we can be able to measure this extent or the degree measure that I've just indicated. Now this is the first case. Now the second one, it can be measured using the concept of radians. And radians is the relationship between, there is an arc length that I've, let me just use a different figure. So suppose we have maybe an array that is maybe just, I'm just using this arbitrarily. Let me just use the x and y axis. But suppose there's an array that runs from this point of origin on the vertex to point B, and there's another one that runs to point A. So depending on which position this ray has moved, either way it's going to form an absolute quantity, which is going to be an angle, extent of angle theta. If it moves from point B to A, it's going to form theta. From A to B, it's going to form absolute value for the degree of theta. So in this case, suppose the point of origin is O, the distance that is going to be covered from point A to B can be referred to as S. So therefore, the one that I've referred to as an arc can be referred to as an S as the distance. And therefore, the distance from the center to end point in a circle, we usually denote it as R for radius. So therefore, OB or OA is the radius. So whenever the distance moved from A to B or B to A respectively is equivalent to the distance OR, we call this one 1 radian. Therefore, a radian measure for the extent of maybe rotation of from for ray AO to OB, to OA, which is theta, is 1 radian if this condition holds. S is equivalent to, or S is equals to A. So therefore, we can be able to say that, just a minute, we can be able to say that 1 radian can be given as S over R. So if this is the same as this one, we can just be able to divide by R. This factor multiplied by a coefficient of 1 is just R. So therefore 1 radian can be given as S over R. This is a relationship that we're going to see maybe if the degrees have been mentioned in radians or the degrees have been given in different quantities. So basically this is the concept of trigonometry that we're going to learn. Now in our second video, we're going to look at the basic trigonometric functions that we come across, the inverses and maybe 1 or 2 of their applications. So this is it for today, guys. I hope that we have captured a point or two from this introduction to trigonometry. And in our next video, we're going to give an example of how these trigonometric functions or the concept of trigonometry can be used to solve problems, or 1 or 2. So that's it for today. Bye. God bless.